why do we need privacy-preserving AI? Well, the biggest issue is data, right? So everyone's been talking about how do we access healthcare data, how do we access government data, and how do we use it without actually revealing the underlying data behind, say, a patient's conditions or the spending behind an individual. So there are actually really interesting techniques that scientists and researchers have been working on. The first one, and I apologize, I didn't realize the screen would be that small, so you can't really read it. The first one is data anonymization, and it may seem simple to just get the data set, remove the names, maybe add some random data here and there, and that could be your solution. But I'm here to tell you a story. So in 2006, Netflix actually released a huge data set on movie ratings. They had 100 million records, and they had about 17,000 movies, 480K users, and essentially what they did was they removed the names from all the data sets and added some random data here and there. But in 2008, two computer scientists were able to launch something called a linkage attack. And a linkage attack is simply just getting another data set, say for example from IMDb, which is an open movie rating website, and connecting it to the data set from Netflix and identifying people who made those movie ratings. Now, I know movie ratings aren't that important, you probably don't care, but you rated, I don't know, Slumdog Millionaire, whatever movies you watch, right? But this is actually really important because if you launch patient data, which actually happened in the mid-1990s, you can do these linkage attacks and find out patient data of specific people. So, what are the solutions that people are working on? In fact, what are we working on at Perlin? So this is just 3 different solutions. There are many more solutions out there, but I'll sort of go over the basic aspects of what they are. So homomorphic encryption, I'll sort of give you an analogy to explain it. If it was a black box, completely isolated, you have a lock for that box and a key. I put in a piece of clay into that box, I then lock the key, I lock the lock and take the key away. I then give someone access to the box through a special set of gloves that they can put their hands in and mold the clay or do some work to the clay. But they can't actually take the clay outside. So that's essentially what homomorphic encryption is, being able to do work on encrypted data without actually having access to the underlying data. But I, as the user, can come up to the box, unlock the box whenever I want, take out the clay. Okay? However, to do this in computer science is actually very expensive. So it's about 10,000 or 1,000 times the cost of a usual computation. So this one we're working on, and we're actually doing research ourselves, and I know people in India are doing a lot of research. But at this stage, it's not exactly feasible to do a computation at 1,000 times the cost. The second one is kind of interesting. It's around differential privacy, which is more of a statistical model. The way you can think about this is every time you take in a data set, for example, if you're voting on yes or no, you take in that data set, and there's a probability that it won't take that data set and just put a random number instead. What that means is, unlike before where you were anonymizing the data, every single data point you're collecting now has a probability of being wrong, which means you can't actually do a linkage attack, which is quite interesting because this is one of the ways that you can do it without having any computational overhead or very low computational overhead and statistically significant results. So this is something that we're building out, a differential privacy engine, and there's a lot of research being done on this area as well. The final one is secure multi-party computation. This one is more about trusted nodes. So I won't go into too much detail, but essentially it's trusted nodes taking in private inputs and then coming out with some computation. The implications of this is quite limited at this stage, and there are a few companies working on this, but at this stage the first 2 are a bit more promising than the last one. The other big issue that I see sort of coming up, and there have been people talking about supercomputers for AI, is the fact that AI takes a lot of computation. In fact, the rate of increase of computation is 300,000. This is a stat from the CTO of OpenAI. However, if you look at Moore's law, which is, we double compute every 18 months, there's going to be a point at which we sort of eclipse that number. And it might not be tomorrow, might not be next year, could be in 10 years. But nonetheless, we need to start thinking about computing resources. And another interesting stat is that we only actually use 9%. We have a 9% utilization of our laptops and computers on average, and about 21% utilization of our mobile phones. And the servers that we use at AWS, etc., only 30%. So as a society, we're being quite wasteful of our computing resources, which is not an issue that people really talk about. So, introducing Perlin. So Perlin is a decentralized cloud computing company. We're essentially an Airbnb for cloud computing. We connect mobile and laptop resources to people that might need it. For example, a lot of people in this room, AI scientists and machine learning people. So the way we do that is that we have our own virtual machine, which is based on WebAssembly, which you install on your mobile phone or laptop or any sort of device that you can think of. And then we have this software development kit, which has privacy tools and anything you really think of to build out models that will run on this. And the benefit to machine learning and artificial intelligence individuals is that we're actually much cheaper than our alternatives as well. So a bit about our company. We have about 100 venture capitals and funds invested in our company right now. We have offices in Singapore, New York, and Hong Kong, and soon hopefully India. So this is one of the expansion markets for us, and we're very happy to be invited here to talk to you all as our partnership with NITI Aayog. And as you can see, partnership with NITI Aayog, Telkom Indonesia, and some other amazing people that have helped us on this global journey. Two of the big focus areas for us is actually India and Indonesia. And I think, Ira, did you want to come up on stage to announce the big announcement, I guess? Yeah? So, I mean, yeah, first of all, thank you very much to everyone for inviting us down here. What we really wanted to announce to everyone today, and my slides still working at the perfect time, but, can we get my slides up? Okay, I'll just talk about it, and you can pretend that there's visuals there. There you go, okay, kind of ruined it. But, we are announcing a global hackathon with India and NITI Aayog. So this is the AI for All Global Hackathon. We have judges from all over the world, Sequoia, IBM, Telkom Indonesia helping out. And what we're doing is inviting you all to submit machine learning and AI models to solve social impact issues in India and Indonesia and also across the globe. So, yeah. So all you have to do, we're actually launching it today, so you just have to go to perlin.net/hackathon and you can submit your ideas for stage 1. You don't need to do any coding or anything like that, it's just simply submitting an idea. Stage 2 is where you get your hands on our decentralized cloud platform, where we'll give you some free credits to build out your models and come up with some cool ideas around privacy-preserving AI and social impact. Yeah. Thank you. Do you want to add anything?
No, I think I'll just start.
Okay, cool. So yeah, I'll hand over to Ira to talk about India and privacy-preserving AI, and also, yeah, what we're doing together.
Thanks, Ajay, for launching the hackathon. So, just to give an introduction, so the one consistent theme that has, that we've seen in this conference has been, this debate, or rather this conflict between, privacy of individual data and, common good for the society. And at NITI Aayog, I think it's very important for us to share our perspective on this, on privacy-preserving AI, on going beyond just the legal and regulatory frameworks, how it aligns with our national strategy, and what we propose to do next. So just a quick, so just a quick background establishing the case for privacy-preserving AI. So this is something that we all know that the issues on privacy and security of data are centered on data collection without consent, privacy of personal data, unethical use of data, companies acquiring large data sets and gaining an unfair advantage, which leads us to our debate on, I'm sorry, I'm so bad at this. Which leads us to a debate on, utility of rich data and artificial intelligence versus concerns on privacy and ethical use of data. So, on one hand, we have this, as individuals, we own and generate data that could, potentially transform healthcare, education, distribute resources more efficiently. And I'll give you an example. For example, data on, let's say, our diet, our sleeping pattern, our geolocation data could inform us, could help us build AI models that inform users about their habits, about how to improve their diet, and give other kind of patterns, and give them predictions and give them more meaningful insights. So AI models require rich and granular and quality data to give meaningful insights to users. But on the other hand, there's a discussion on how organizations are misusing this data to gain an unethical advantage. How they could be discriminating, how they could be profiling. So what is next? How do we find that middle ground between these two debates so as to deliver the benefits of AI to users and also protect their privacy? So one potential solution could be looking beyond the whole legal and regulatory frameworks, which are also very important. How can technology help us address this problem? So which brings us to privacy preserving AI. So I'll just, Ajay has very well, given a brief primer on the different techniques, but I'll just, give our sort of just a very simple two illustrative models on two approaches for privacy preserving AI. So one is, for a single user, let's say, this is on separating data and compute. So you have a person, you have an individual, let's say A, and she wants to perform computation, addition between two numbers. So instead of sharing the raw data with the server or the device that will perform the computation, she only sends the encrypted data. So the homomorphic encryption, it's called homomorphic encryption. And it encrypts the data, and the server or the system only performs the computation on the encrypted data. It then sends back, the system decrypts the data, and it sends the result to the user. The user receives the result. So this way, no raw data was shared between the user and the server. So another approach could be, and this is called multi-party computation. This could be used for multiple users. Is that you have a central server which has let's say an untrained model, and that is sent to more than one individual. You have three, in this case three nodes, three users who have the data on their local devices, and who also use that device to perform computation on that data, and then send back only the change caused in the model to the central server, which then updates its AI model. So this also has the twin benefit of utilizing computing more efficiently. Now the core of this discussion: why is privacy preserving AI important for our national strategy? So the success of digital infrastructure projects like UPI and India Stack have really ushered India into an age of innovation. As an illustration, I'll talk about the recently proposed National Health Stack, which is an integrated digital healthcare system, and it aims to create master health data for the nation, which is integrating all health records across center and states. So a technology like this could be very, very crucial, when Ayushman Bharat scales. So the key components of this proposed health stack is federated personal health records and privacy by design. And it's very encouraging to see that there's a shift from centralized to a federated approach, which, so in that approach, I'll just briefly explain what it is. So individuals, users have access to their personal health records, and they will be the ones who will be deciding, who to give access to, what, like what to consent to, and through an intermediary body called a trustee. So in that case, in a solution, in a framework like this, we believe that we feel that privacy preserving AI could be a very good fit and could potentially unlock the value of these electronic health records, which store they have the entire medical history, billing information, radiology test results, and it could really help deliver personalized healthcare to individuals. So while this area is still nascent, and the research in this area is gaining momentum, solutions of scale are yet to be seen in India. And if going forward, if we can prove the scalability, it would be of value for us to embed this in our national infrastructure. So the way forward for us would be, we collaborating on pilot projects, for example, use cases, applications in healthcare and financial inclusion to study the scalability of these techniques. Investing in areas of research like differential privacy, privacy by design, safety critical AI, multi-party computations. We could introduce these as, as research topics or areas to study in, the cores and ICTIs that we propose in our national strategy. And, in the future, when the national data marketplace, is, we have a framework. We already have a framework for that, but once it becomes complete, we can integrate this with privacy-preserving AI techniques. We've also just today launched a hackathon, which Ajay introduced, AI for All hackathon, which is a first of its kind hackathon on privacy-preserving AI and distributed computing. And it's already live. And it's a two-stage hackathon. In the first stage, we are just inviting proposals on AI, AI proposals on use cases in the social sector, in healthcare, education, urbanization, mobility, agriculture. And in the second case, in the second stage, we will be, evaluating the solutions on, on their whether how well do they, utilize distributed computing. Do they have an element of distributed computing? How well do they understand the privacy-preserving AI? And then, of course, they'll be mentored and they'll have access to the libraries, I believe. And so I think this hackathon would be a very good medium for us to look at solutions and see if we could potentially scale them.